All right, in this video, we're going to attempt to get the color node to work properly with Arnold materials. Now, I have just a normal, uh, basic setup here. Nothing too crazy. I have some looping noise. It's 100 frames. Three different objects. I'm using the replicator node, the ID node. So basically, everything that I just talked about in the previous lecture. So what we're going to do next is try to get that color node to work with our Arnold materials. So right now I have just the basic standard material applied to everything except for my spheres. My spheres, I have an Arnold material on. So if we just do a render of this, so just let's look at the Arnold render here in our viewport. Get what we would expect, right? I'm going to go ahead and stop that. My audio may cut out while I'm actually rendering, so I'll try to keep that to a minimum. But now let's go ahead and add a color node to our network. So we'll go to our mesh node and we'll add a color node. And you see that our color here is set to white, so everything goes white, of course. We can change this to a different color. Let's go like something like blue. And then we'll come down here to random hue and start doing a random hue. I kind of like how it was all sort of blue or cooler tones, so maybe something like that. We can do random saturation to get, just random nodes or random variation. And the one thing that you'll notice right off the bat is that it's working on everything except for our spheres because they have an Arnold material applied to them. So even though these spheres are a part of the same network, the color node isn't working on them. So there's a few things that we need to do. And let's go ahead and do a quick render just so we can see the result that we're getting from this. And I'm going to save this file too, just in case we crash, because that's not unheard of. So I'm just going to name this mash test one. And we'll go ahead and see before it's not working in our renderer. And that's mainly because we're rendering something that's not native. Now, there's kind of a complicated way to fix this. It's a pain in the butt, but it should work. I just have to remember how to do it. So you may need to bear with me here for a moment or two. The first thing that we need to do is go to our mesh object, and we need to go to the mesh shape node, I believe. Or actually, we need to go to our mesh repro mesh. We need to go to this this node, and we need to go to the shape node for that repro mesh. We need to go down to the Arnold tab. We need to go down to the export value, and we need to export vertex colors. So that's the first thing that we need to do. Okay. Now the next thing that we need to do, I need to actually remember what node we're supposed to do this on. And like this. You can, for example, we'll see the color. Oh, it's green. This pink 3. But in here,
let's just repeat this. Go to the mesh shape, to export on the vertex, go to the mesh repro, and color to vertex should be exported. Go to the shape material attributes, that's the green one we just chose. And now you need to go here and type in data. To utilities, you find a few this data utilities, and you need the data color. So before I activate this, here you go to it's the repro mesh. Shows green standard. So now with the data type in, it's my fault, color set.
All right, so the next thing we want to do here is go to our repro node, and we want to come down and make sure under output we have color per vertex applied. And then the next thing is going to be on a per shader or per material level, and it's something we need to do in the sky, the hypershade. So I already have an Arnold material on my spheres, so we're just going to do it to the spheres and see if we can get that to work first. So I'm going to open up my my hypershade here. That's not my hypershade. Here's my hypershade. I'm going to expose my standard surface material here, and we'll go ahead and map that out in our hypershade. And what we want to do is attach a user data node to our color input. So it's basically we're going to send the color to that color node in Mash. So I'm going to hit Tab. I'm going to type in data, and what we want is AI user data color. And then I'm just going to middle mouse drag that over into our color. So we could do this for anything that we want the color to be driven by for this material. And then under attribute, I'm going to type color, lowercase, no space, capital S, ET. So color set. Okay. Now, when we render, it should work. So let's test it out and see. So I'm just going to minimize my hypershade, and we'll do a render, see what we get. So now we get our variation in color. So I'm going to do this to a couple other objects. I want to add different materials to each of my objects here. So we will go ahead and quit my render so it's not going nuts on me. What I want to do is add materials to everything else. So for my my cylinders here, I'm going to back out of my render here. I'm going to unhide my cylinder, Shift H, pull that over to the side here. We're going to assign a material to it, and I think I want this to be like a emissive material, so I'm actually not worried about it matching the color node at all, because I just want it to emit a little bit of light. So we'll go ahead and do assign new material. We'll do a standard surface, and I'm just going to come down to emission and crank up the emission on those to maybe something like 2. Okay. And then my my other cylinders or my cubes here, will unhide one of those as well. Pull that to the side. We'll assign a new material to it. Oops. Okay. Assign a new material to it. Assign a new material to it. There we go. Surface, a standard surface material. And we'll go ahead for this one and jump into the hypershade and go ahead and attach that other node to where I want it to be. Now, this one I want to look a little bit different, so I may plug this into a few different places. So let's go ahead and expose that one, which is probably going to be 4. That's the last one that I created. And I could probably use the same node that I have on my other one, on my standard. See, it's going to be the standard 1. So we have standard 1, 2, probably standard 2. So we'll just expose both of those. Yeah, so that one has that user data node. I'm just going to take that same user data node and we'll plug that into the color for this guy. We'll plug that into the specular color as well. And I'm not going to have any transmission on it. So yeah, so now we have that should be driving the color for our Arnold material. So let's close out our hypershade and give that a test. So I actually want to make this one, this material here, look like metal. So we're going to increase the metalness on that one. Let's go in and take a look at what our render looks like after we save. So save first. Yeah, so now we're getting a pretty neat outcome. I'm going to be quiet for a few seconds and just tweak some of my settings to get these to kind of look the way that I want, and then we'll continue from here. So I may speed this up in a little time lapse. All right, so I have this looking like I want it to look. So that's, we have our color node set up there working properly. We can hit play. We can see our slow animation. It's only 100 frames. It is a looping animation. So the next thing we want to talk about is rendering and how we can get our denoiser to work. Now, your denoiser should work in conjunction with your render settings. So if your render settings are too low, if you're getting too much noise, um, and you use your denoiser, you're going to get like this really blurry, kind of weird looking result. Um, if your render settings are too high, your denoiser is going to end up not really doing anything, and it's going to take forever to render anyway. So I want to get sort of a medium result here with my render settings. So I'm going to start and maybe do another time lapse where I just don't say anything, just kind of tweaking my render settings, my sample rates a little bit, so I get sort of like a medium quality result. I'm looking for maybe a few second render per frame, maybe 20-30 seconds at the most. Um, and I'm doing 100 frames here, so ideally 10 seconds per frame would be good for just this demo. Obviously, if I have a lot more going on in my scene, if I want it, if it's a higher resolution, we're not doing 1080p. I'm only doing 960 by 540 as an example. So your render times will probably take much longer than this. This is just an example to show you how things work. This is not what I want you to do. I want you to have a much higher resolution, higher quality render. And ideally, I'd like you to have a more complex Mash network than this. This is a fairly simple Mash network that I have going on here, and it's truthfully, it's not. I'm trying to make it as visually appealing as I can, but it's not. It's not the most visually appealing Mash network. With that said, I'll do a little time lapse where I'm just tweaking my render settings a little bit, trying to get a little bit of the grain out of my render. All right, with this, we're looking at about 28 seconds per frame. There's still a lot of grain in here, but I think this will be a good opportunity for me to show you the downside of the denoiser. If you do use a denoiser with too low render settings, the issues that it can cause. With this being pretty solid, there's no textures or anything. Everything's pretty much a solid color. I don't foresee there being a huge problem, but I could see there being a lot of problems with these guys here in the background with a lot of noise here. So let's go ahead and maybe get a different angle going here where we can see a lot more going on. Maybe around along the lines of that. So what else do I want to do before I actually click the render button? I do want to go in and I want to add a little bit of motion blur. Anytime you have movement, you want to add motion blur. Now you can add motion blur in post in something like After Effects if you want. Um, I'm just going to go ahead and enable it and use the default settings here. That should give me some pretty good results. If you don't use motion blur on your animations, it just won't look right. There's always going to be, it's going to be a little off because the way the human eye works, things blur as they move. So I'm just going to turn it on. I'm going to use the default settings. And as far as anything else goes, I'm not going to change anything else. Now, depending on your scene, you may want to go in and change your ray depth if you have transparency or, again, go back and look at those textures and lighting lectures if you've had that class, and that will help you a lot with these settings. The next thing I want to do is, of course, save. I'm going to keep saving because I know it's going to have I just feel it's going to happen anytime it's going to crash. Um, so the next thing I want to do is go to my AOVs tab and I want to go to denoiser and I just want to turn on output denoising AOVs. And your optics denoiser, that may work as well. Your optics denoiser only works in IPR. So this one actually works. It's really easy. You just turn it on and then whenever you render, you can go and choose your beauty that you have, your beauty render that you have that applied to. So this will work in your IPR pretty well. Otherwise, you want to go to your output denoise, turn that on. I don't believe we need to go in and create an actual AOV, but you can, of course, if you want. And then we want to go to our common tab. We want to make sure that we have merge AOVs turned on. And we want to, I like setting my compression for my EXRs to none. I just feel like it reads in Photoshop better if there's no compression on it. I'm going to come down to my frame range and we're going to do frame animation. We're going to do frame underscore number dot extension. This is the one that you should always do, is that bottom one, frame underscore number dot extension. I have 100 frames here, so a frame padding of 4 is fine. That's going to give us a 0 in front of our digits. I'm going to change my in frame to 100 because we have 100 frames. Everything else looks good. I'll go ahead one more time and save my file. I'm going to click go to render. This will not work just doing it in the render window. You have to either do a batch render, which we all know will give you an ugly watermark because Arnold hasn't gotten rid of that yet. Or you can do render sequence, which is what we're going to do. So I'm going to hit render sequence. I'm going to stop the recording, and then we'll come back when it is done rendering. Before you hit render sequence, the one thing that I would do, because this gets very annoying, is I would bring up your render window, your Arnold viewport render or your Arnold render window, this guy. When you do render sequence, it use this. It uses your Maya render window. So I'm going to go ahead and bring that open like that. Because otherwise, if you just hit render sequence, it will pop open in an area that you may not want to see it. And mainly, it'll hide this bottom left area here. And if you hide that bottom left area, you can't see your render progression. Normally, that will tell you how far along in the renderer you are. Here as well, will tell you what frame you're rendering on. So I don't want to hide any of that important information. So I want to open that renderer first, or that render window first, and just place it somewhere, even on another monitor is fine. Actually, I'm going to do that. And now we can go to render sequence.